Okay, learning objective 5E, show an understanding that the weight of a body may be taken as acting at a single point known as its center of gravity. So what is the center of gravity? Basically, the center of gravity is the point at which the weight of his whole body appears to act for any orientation, right? So the weight is the point. So this point here, this is where the weight will act. Okay, so you can use this weight for reference for doing things like principal moments or stuff like that. Calculating its moment and things like that. Okay, so explain why the boy cannot raise his left foot off the ground without losing his balance. So they tell you which is left foot, right? So if you lift off the left foot, what will happen? So the left foot is off the ground, right? What will happen? Well, let's look at the center of gravity. You see the pivot. Where will his pivot be? His pivot will be this foot. His moment, the weight would still be here, and it will still be acting downwards. Sorry. So what's the directional moment about the pivot if the left foot is lifted up? Yeah, it would be let's use this clockwise, right? Clockwise about the pivot, which will be his right foot, right? And there's virtually no way to shift his center of gravity over his foot because the wall is here. So explain why. Basically, it's because there will be a resultant moment, right? So when you talk about why something will tip over, why something will turn, whatever, you need to talk about moments and the resultant moment. So let's explain that. When he raises his left foot, his right foot becomes the pivot. So firstly, you need to identify the pivot. So his weight, which acts downward from his center of gravity, so because it's downward, it will exert a clockwise moment about his right foot. And because it exerts a clockwise moment on the right foot, it will cause him to rotate clockwise and lose his balance. Okay, so fairly kind of like straightforward kind of answer. You're really just explaining where's the pivot, where's the force, and so where's the moment, right? And so what will happen. Okay. Next, question 8. Another thing that requires you to know the center of gravity. On the figure, draw an arrow to represent the weight of the meter rule, right? So this is a uniform meter rule. So for uniform objects, where is the center of gravity? It's in the middle of the object. So where would the weight be drawn from? This is 10, 20, 30, 40, 50, right? So meter rule, so 50 cm is in the middle. This would be the center of gravity. So this would be the weight. Okay, it's probably not going to be this heavy, but whatever. Okay, so weight or so this is part A. Okay, it'll be good to label your answers like so. Okay, so calculate the weight of the meter rule. So now that you know that the weight acts from here, how do you calculate the weight of the meter rule? It tells you that the rule is balanced horizontally. Again, what do we say once you see these words? What happens? You know that you're using the principle of moments. Okay, so so let's just write down the principle of moments. Sum of anti-clockwise moment equals to sum of clockwise moment about the same point, which is about the pivot. This is the pivot that we're looking at. So let's identify the directions. This one is this way about the pivot, so this is this way is anti-clockwise, right? This one is this way, right? This way, so it's clockwise. This one is this way, so this is also clockwise. Okay, so great. Now we just need to put them on the right side. So sum of anti-clockwise moment, I only have one thing here that's resulting in an anti-clockwise moment. That's a 4 Newton force. So it's my force times perpendicular distance, which is 4 newtons times perpendicular distance. What's my perpendicular distance? What's the distance again? The distance we're looking at is from the pivot to the line of action of the force, right? So the force is here. The distance is this one, right? So be really careful here. A common mistake that students will make will simply put 10 cm just because it says 10 cm here, but the distance you're looking at is between the force and the pivot. And so the distance between the force, which is here, and the pivot is 10 cm. This is 35 cm mark, so this is 25 cm, isn't it? So this is 25 cm. And then sum of clockwise moments. So let's take a look at what are the clockwise moments. Let's write out W. So our weight times what's the distance from the weight to the pivot. So if this is the 50 cm mark, this is 35, so the distance between here is 15 cm. Right? And then this is 1, my other clockwise moment is this one, due to this force, so it's 2 newtons times, what's the distance here? 80 minus 35, which will give me 45. Right? So I just need to solve this mathematically, and I'm going to end up with weight equals to 0.667 newtons. Alright, 3SF. Okay, so yeah, the key thing here is knowing which distance to use, and of course knowing the center of gravity is in the middle of the object. And so when you use the weight, when the weight is not negligible, note that the weight is usually in the middle of the uniform object, and use that to calculate the distances. Okay.